All right, chapter 3. Great job, made it through chapter 2 finally. Chapter 3 is on really getting into detail with probability now. The first section, not as tough as the second section. We're going to get right into it here. Section 3.1. Okay, so a bunch of probabilities here a bunch of properties here of probability. So some of these are going to look familiar, right? It'll look a lot like when we did numbers and sizes of sets. So a lot of the same properties. So probability of E complement, that's just 1 minus the probability of E, right? So probability of rolling a 5 is 1/6. Complement of that, 1 minus that, so it'd be 5 out of 6. Okay, if we have something that is pairwise disjoint, in other words, the sets, if we think about a Venn diagram, they do not overlap. Okay, if I want to find the union, it's just first one plus the second one. That should look familiar. When we had, instead of probability, we just had a little n there for how many were in the set. Same deal. Okay, that only works again if they are disjoint. All right. If they're not disjoint, we've got another one which you probably remember from section 1.3. Okay, so any event is, if I want to find the union, it's the probability of the union. It's probability of one plus probability of the other one minus probability of their intersection. Okay, that works for disjoint also. If they're disjoint, probability of their intersection is just 0. So that's why that part's not there in the other form. Okay, so that's probability of the union. And again, we subtract out the intersection, remember, to avoid double counting, right? So otherwise you would count that intersection twice. Okay, big hint on this, use Venn diagrams. Most of the problems you're going to see in this section are using Venn diagrams. So first example here, get rid of that. So looking at the point of sale terminals in a store, in this case an electronics store, record info about the time of each sale and what goods were sold. Manager is interested in when the high value sales occurred. So high value sales were over $500. We've got some probabilities for each of those. So you see sale, so before 6 p.m. at a high value, 0.05, before 6 and not high value, after 6 and high value, after 6 and not high value. So we can make a Venn diagram representing this. So basically I have two outcomes. One is the time and the other is the value. So if you think about a Venn diagram, so for my circles, we could have, we've got a couple options actually to get the right answer here. I'm going to use the one circle as before 6. So before 6, and then the other one being the high value. So high value. Okay. So we'll start with that. So before 6 and high value, 0.05. Right? So now before 6 and not high value, so think about where that has to be. So we're in the before 6 circle, but we're not the high value, so that's the other part of that circle. So that's the 0.26. Okay, after 6 and high value, so now we're in the high value circle, but we're not in the before 6 one, we're after 6. That's 0.17. And then after 6 and not high value, that's in neither of the circles, so that's what's outside. Okay, the next slide is going to have some questions. You could still answer the questions if you did the Venn diagram differently. If you had after 6 and high value, or you had after 6 and not high value for your circles, doesn't matter as long as you put the numbers in the right spots. They would just look a little differently, but you still get your answers the same way. So looking at the questions now. So probability of a sale before 6. So that's just everything in that circle before 6. So that's the 0.26 plus 0.05. So that would be 0.31. Okay, probability of the sale after 6, so that's everything outside of that circle, which I can get that's just the complement. So 1 minus 0.31, or you can just count up everything outside that circle. Okay, so 0.69. And then after 6 or high value. So after 6 or high value. So remember, or, okay, Starbucks or cream or sugar or both. So that's after 6. So that's after 6. That's after 6. Or high value. So this includes, that's also a high value. So we include that also. So it's everything except that 0.26. So 0.74. All right. So that's one way we can use Venn diagrams. Setting these up. Okay, next one. This should look very familiar to some of the ones you did back. It was just sizes of sets. So we might have had, if you think about this as the probability of E is 65, F, or say like number in E is 65, number in F is 4, number in the intersection is 0.3, or is 3. It's the same way. So we want to find the union. So we could do this with our formula or Venn diagram. So I'm going to show both. So we have E, F. So remember, always start in the middle if we know it. In this case, we do know it. So 0.3. And we work our way out. So probability of E is 0.65. So 0.35 goes there, remember, because all of E has to add to 6.65. F is 0.4, so that leaves 0.1 over there. Okay, if we needed the outside, all this has to add to 1. So if we did do that, this is 0.75 in the circles. We don't need it for this problem, but 0.25 outside. I want E union F, so that's just those, so 0.75. If you wanted to use the formula, okay, remember that's just the probability of E plus probability of F minus probability of the intersection. So E is 0.65, F is 0.4, the intersection is 0.3, also gives you 0.75. All right, so we got two options there. Sorry, you have two options there. All right, a little more complicated one now. Now we have 3 sets. Okay, so let's draw a big old Venn diagram here. Okay, so if you need to, you might need to go back and review some of the Venn diagram information, especially for this part. Some of these get tricky if you don't know how to find a certain spot. If we do that, if you wanted to find that, let's draw this up here. So remember how to do it. So we have parentheses. So it's A intersect B union C. So B union C is everything, all those, right? And then A is all those. And since it's A intersect that, it's whatever was checked twice. So basically, that area is what it's talking about. Okay? So, going through our information now. A union B union C is my sample space, meaning there's nothing outside. That's what that's saying. So, nothing outside. A intersect the union of B and C, that's what we just found. That's the empty set. So, meaning we have zeros all throughout that area. Okay, probability of A is 0.2. Well, all that's left for A is this little part over here, so that's the 0.2. Okay, and then B is 0.5, C is 0.7. We don't have enough information yet to put those into the diagram. Okay, so let's start looking at what we can do. First off, probability of a complement, that's whatever's not in A. You can either look on the Venn diagram or right here. A complement 1 minus A, so 1 minus 0.2, A complement is 0.8. So now, B union C, think about what is that, okay? And what is A complement? If you look at A complement, look at where all the zeros are. We know A complement equals 0.8. So that means that, and that add to 0.8. We have zeros in all these spots, meaning B union C, if we put all of B union C together, that's just A complement. That's just the 0.8. Okay? So there's nothing outside 0.2 over here. So B union C has to be the 0.8. And then if I want B intersect C, now I can use my formula. B union C, remember that's going to be B plus C minus their intersection. I have all that information now. Okay, I have B union C, we just figured that out, was 0.8. B, we're told in the problem, is 0.5. C, we're told in the problem, 0.7. I can find my intersection, so that would have to be 0.4. Okay. So a lot going on there, Venn diagram, and kind of just applying that previous knowledge to figure these out. Okay, so another one. This is kind of a tricky one to understand the reading and everything. So we've got a quality control engineer inspecting widgets, very exciting object to sell and make. Widgets on a production line of a factory. Randomly selected widget can be acceptable or defective. Okay, it says so acceptable or defective. Defective are either mismanufactured. So mismanufactured means too large, too small, or mislabeled, or they could be both. Okay, and we've got probabilities based on past data right down here. So ones that are good to go are 0.72. All right, those either were acceptable or were not. So acceptable, those are all defective. Okay. So if we then look at a few more things here. It says they're either mismanufactured, so which meaning too large or too small. So those are the ones mismanufactured, or mislabeled, so the incorrect label, or they have the right label in the wrong spot. Those would be mislabeled. Okay. So now, if you want to go in and figure out some of these probabilities, probability that a randomly selected widget is mismanufactured. Just go back. After reading carefully, we figured out that's either too large or too small. So you can't have it be both. So 0.12 plus 0.08 would be 0.20. Okay, not mismanufactured. Well, if it's mismanufactured, it's 0.2. Then not mismanufactured would be 1 minus that, 0.8. Okay, mislabeled. Let's go back. There's my mislabeled. 0.15 plus 0.02, so 0.17. So not terribly hard once you kind of understand what, read everything carefully, look at the fine details. All right. Last example here, I believe, make sure of that. Yeah. Last example. So this one looks super duper hard. I'm going to show you an easy way to do it. So we have E, we have F, we have G, we have the intersection of all those. We don't have the intersection of everything. Okay. So your notes, don't write this down because I'm going to erase it and do something different. We could start, and we can do it this way, where I just write them off. So I have 3 sets. I don't know this, okay, but I do know my intersections of each one. All right, like I know E and F together. I know that. I know E and G together. I know that. All right. But really, if we look at my questions, I don't need that middle intersection point. We don't need to worry about it. Okay. So rather than drawing one that has all three sets put on there and looks like a big mess, we can draw three separate Venn diagrams. So I can draw one with E and F. Okay, I can draw one with E and G. And I can draw one with F and G. Then I can solve my problem that way. Okay? So if you look at the E and F one, so E intersect F, it's 0.15. So then I can find that little part of E that's not in F. So since it's 0.35 for E, that's 0.2. F is 0.45, so this little area would be 0.3. Okay, outside I don't think we need it in this one, but we'll do it anyway. So we've got 0.5, 0.65, so that's 0.35 outside. Okay. You go and get all the other Venn diagrams done, and then we'll answer the questions. So E and G, the intersection of E and G is 0.12, meaning since E is 0.35, so that leaves us at 0.23. G is 0.55, so 0.43. Okay, this one we do need what's outside, or we will. So we have 0.55, 0.75, 0.78, 0.22 outside. Then if we look at F and G, so F intersect G is 0.1. F is 0.45, so that means 0.35 is there. G is 0.55, so 0.45 is there. So that's here, 0.8, 0.9, so 0.1 outside. Okay. So now I've got those, the problems are not really that difficult. Just remembering what the expression here is describing. So E complement intersect F. If you remember, all that is just the little, so it means what's basically only in F. So it's just this little half moon shape, so 0.3. Okay. F union G, so now we look at that one. So F union G, we just need to add those three up. So that was 0.9. Then E complement union G, if you forgot how to do that one, that's one that sometimes people might forget. So E complement is those two. G is those two. Since it's union, it's everything that's checked. So it's basically everything except that 0.23. Okay? So 0.12 plus 0.43 plus 0.22 should be 0.77. Okay? So draw your Venn diagrams, pay close attention to detail in each little part, what it's asking, and this section doesn't end up being too terribly bad. So come with questions. Hope that went well.